with all that we have explained so far, right, and having to have pointed out the midpoint theorem from this formula, it was all based on the fact that they told us that we have a diameter of a circle. So from the diameter of a circle, we said we got this as 90. This we got it to be 90 as well, and then these are equal because of theorem 1. So much information. And then here they told us that the length of the radius is 10. So if this is 10, it means that this is also equal to 10.
Yes.
The diameter is 20. So that's fine. They then said here these are parallel. They told us that, which is good information. And then they said here now we should calculate the size of angle C. State a reason. So we already stated a reason, right? Why C is good to 90. But so when you will be writing it out on the answer sheet, what would you write to say that C is a 90-degree angle? How would you write it?
Could you not say like angles in semicircle?
Yes, angle in a semicircle. That's correct. You're gonna say angle in a semicircle. So I'm actually just looking for space to wait to I'm looking for space to write, but I'll just write it here. Let's see. Angle C, right? So C is equal to what's the thing? 90. You said the reason is angle in semicircle,
Yes.
right?
Yes.
Yeah. And then the second one, it says what is the size of E1? So what would you say is the size of E1 and what's the reason?
It should be equal. It'll be 90. And could you say corresponding angles?
Yeah, 100%, bro. 100%. That's definitely correct. And then it says y is AE equal to CE. Why are these equal?
I wanted to say something about like how the line bisects it, but then I don't know what would be a reason for that.
Yeah. So when you're going to give a reason why AE is equal to EC, you're going to talk about this line cutting this chord in half. You see,
Yes.
or rather, you're not talking about this line cutting the chord at an angle of 90 degrees. You see. So for 3, you can say that OE is perpendicular to AC. That's the reason. As long as OE is perpendicular to AC, it means that this is being cut in half. You see, because OE is a line from the center of a circle. You see that. So the previous
Yes.
question is what helped you to say this statement. You see, this will be your reason. Is that fine?
Yes.
Yeah. The next one says if AC is equal to 16, calculate the length of ED. So where is AC? AC is equal to 16, right? So if AC is equal to 16, you see that they're already giving us the length here, which is just gonna be 8. This is also gonna be 8. You see?
Yes.
So the one thing we should not forget is that if this is 10, right, and this is also equal to 10, it means that OD is also equal to 10. You see that?
Yes.
Yeah. So let's maybe not forget that.
Oh, yeah. I see. Yeah.
Yeah.
Okay.
So if they say this is 16, let's see how that can be useful, because they then want us to calculate the length of ED. So you getting ED, you don't focus on getting ED specifically. So just by looking at the information given, what can we do to get ED?
Um. If yeah, I don't know what we would do, but like let's say now what I'm thinking is if those lines are bisecting and the line what do you call OD is also 10. Wouldn't that mean that ED would be 5?
No, remember ED is not equal to OE. The idea with OE here
Yeah.
and ED is that you actually may want to get this line. You see, because if you get that size, you can remove it from 10.
Oh, okay, makes sense. Yeah.
Yeah. Of which, how are we
Also,
gonna get OE?
Pythagoras.
Yes, Pythagoras. You see, so you can do Pythagoras here. You can have the OA squared. You have to be careful to start with the hypotenuse. So OA squared is equal to AE squared, right? Plus OE squared. Yeah. AE squared plus OE squared. There we are. You see.
Yes.
So now we can put in our dimensions, right? 10 squared. AE is 8. OE is OE. This is gonna be 100 minus what is it now? 100 minus, let's see, 100 minus 64 equal to OE squared. If you square root both sides, let's see, what do we get here? We have well, 100 minus 64 is gonna give us like 36. You see, so square root of 36, that's just a 6. I'll just put dimension here. So OE squared, and then OE is equal to 6. So you see, if OE is equal to 6, what is EG then?
ED is equal to 4.
4. Exactly. That's how you get your EG. So you see, we got ED by not necessarily working out EG. We got something else instead, which is the way to go about it most of the time with these Euclidean questions. Always focus on something that has information and then use that to get the part that does not have information. Cool. Does that make sense?
Yes.
Cool. So, all that being said, with the next question, right, it says the one that's circled, which is D. It says here in the circle, or rather, let me make this one a new one. Let's see here.